Hello, it's James from XRobots.co.uk. As you know, if you've watched my channel, I quite enjoy making robots and other costume and prop parts. I do a lot of 3D printing, so check out my 3D printed R6 droid, which is fully 3D printed, radio controlled, and has lots of features inside it. And I'm halfway through building that in my channel. So obviously when the Star Wars Episode 7 trailer came out, there's quite a lot of speculation about a new droid that's going to be in the movie called BB-8. Which is basically its body is a big ball and its dome magically floats along on top, and basically it runs along, and that's how it works. So it doesn't look like the traditional astromech droids with legs, it's just like a big beach ball. So the plan of this project is to try and build a working version of that, and there's been quite a lot of speculation online about how that could work. There's going to be some 3D printing and other materials used and quite a lot of electronics. So first of all I need a ball, which I've got here. This is a 500mm diameter polystyrene ball which I got off eBay. And in fact it splits into two halves and we need to stick that together. It's hollow and it's extremely lightweight, which is actually perfect for what we need to do. It's also quite rigid as a result of being expanded polystyrene. So it doesn't squash and it keeps its spherical shape, unlike an inflatable ball, and the only ones I could really find this size were either, well, not even gym balls, but those really thin beach balls which are quite squashy. So this seems totally perfect, and these come in different sizes as well. So we're going to need a dome to go on top as well, and I've got for now a clear acrylic, also known as perspex or plexiglass dome, which is going to sit sort of just above. It doesn't sit right on there, it's quite a way above, and we can 3D print a base with a little sort of curve piece there. So that's basically going to be the structure of the droid, but obviously what we need to do is make this dome balance on top of the ball. It's going to be radio controlled, so the ball rolls along and the dome stays on top and basically actively balances on there using some electronics. So let's have a think about how that's going to work. So let's talk about how things balance. I've got a piece of wood here, which is quite a lightweight piece of wood. I've got two clamps attached, and that's how I can put this reel of cable on top, which is actually fairly heavy. So we're just going to put that on top, and then I'm going to balance that on my fingers there. And what we find is it's actually quite easy to balance. In fact, I can stay almost stationary and I only have to move my hand a little bit just to compensate. And as long as I keep my hand on it, it's pretty easy to balance, you know. And the reason for that is that the mass on top needs a larger force to move it. So essentially it has quite a large inertia. So it doesn't want to move too quick. So I'm finding that quite easy to balance at the moment. And this stick is about the same height as my polystyrene ball. And my reel of cable is slightly lighter than the robot is going to be that balances on top. So if the weight of course is bigger, then it'll be even easier to balance. So now if I take the cable reel off, we'll find I can still balance it, but it's quite a bit harder because it moves quite a lot quicker. So I have to be a bit more careful about how I balance it. And if I'm not careful, it will fall off. Right, now I'm going to try and balance this pen on my hand. And that's extremely difficult, and that's because the pen is so lightweight. It's got hardly any mass to it, and hardly any inertia, and once it's moving, it's practically impossible to stop. So it looks like what we need to do is have our lightweight ball, which is really good, which has hardly any inertia because it's lightweight, apart from a bit of air resistance, and a fairly heavy robot on top with lots of motors and batteries, and that should automatically give us some mechanical dampening. So basically it won't move too quick, which means it won't take much force to keep it on balance. What we're essentially building is a two-axis Segway, so we're building a robot that can move left and right and backwards and forwards to actively balance on the ball. So to do that we're going to need some wheels that can move in all directions. So what I'm using are these omnidirectional wheels, which are like a normal wheel that turns, but they've got little wheels all the way around the side in two layers. And that means they can actually slide sideways as well as moving as you'd expect a normal wheel to. So I'll put a link of where I bought all of these items on the website, including these motors, which are from MFA Como drills. The wheels came with these little hubs, which have keys in there for a normal Technics Lego black axle, as well as a servo mount. I've actually 3D printed some more here, which push fit onto these motors, and the motors have got a 4mm shaft with a flat on. So those are just a push fit. They seem to work pretty well. They're quite a tight fit. Obviously there's never a situation where the wheel gets pulled off, because it will just slide sideways, so I'm pretty happy with those. There are several ways we could configure these wheels so that they balance on the ball. The sort of ideal configuration is to have 3 wheels like this. So it's a bit like a stool on an uneven floor, which means that all of the feet have to touch the floor, because only 3 of them, so it'll always tip down in whichever direction doesn't touch the floor. And that means we'll get equal traction from each wheel on there. The issue with this is that basically, due to the nature of these wheels, this one can drive in a straight line to move sideways, but then these have to kind of slide sideways and move. And then to move forwards, that one will slide sideways, but these two again will move, but they also slide sideways slightly, which means that we never get the maximum speed of the motor. Of course, we get that in a straight line. And it does make the coding a bit tricky as well, because the electronics are going to have 2 perpendicular axes which we need to interpret, so we'll have to then mix those to the motor. So to make it slightly easier on myself, I think, and to make the robot more reactive so the wheels always move in a straight line, I'm in fact going to use 4 of these, which is why I've got 4. And I'm going to arrange them like this. And that means that if it moves forwards, these wheels obviously move in a straight line. If it moves sideways, they move in a straight line, or any combination thereof. So we get maximum traction on the ball, and we can get the maximum speed out of the motors if we need to. There's an obvious issue with that approach, which is that if the ball is an uneven shape or something weird happens, like there's a lump on it, then it is possible that one wheel can pick off the ground or off the ball, and the other 3 will still be gripping, which means that it will do something weird like spin. So that does add a bit of added mechanical complexity, but I think I can get around that with putting little suspension things on each wheel and having the batteries and various other things applying quite a bit of mass to the top to squash it down. So that's going to be my first prototype, and I may regret it and come back and build a 3-wheeled version. So to make those wheels and motors balance on top of the ball, we're going to need some active electronics with some sensors. The first one of those is an accelerometer. So if I take my cell phone here, I've got a picture of some nice droids on the screen, and if I turn the phone round, the picture always turns the right way up, and that's using an accelerometer. So an accelerometer measures acceleration with reference to the Earth's gravitational field. It's quite slow, but it always knows which way is up relative to gravity. So we could just use an accelerometer, although the droid would take quite a while to compensate. So the other sensor we need is a gyro. You can imagine a gyro being a bit like a spinning top. But if you've ever delved around inside a computer when it's switched on and looked at a hard drive, so I've got one just here, it's not cabled to any power, but obviously it has spinning platters that spin round really quick. So if you've ever got a hard drive or anything that's a motorised spinning disc, while it's spinning and then try to move it, you'll notice that it feels a bit weird and it tries to resist your motions. So basically a gyro is quite quick to react. You can feel it as soon as you turn it, but it doesn't know which way up is. So if you actually force it to a different motion, then it's perfectly happy sat there. So it only exerts a force back on you when you try and move it. So what we need to do is mix the accelerometer and the gyro together. So we've got the absolute upright position with quite slow data. So you can imagine that being like quite a slow sort of wave as we tilt the robot round. And then we've got the fast gyro data, which has creep, which means that if I move it to one position, it doesn't know any different. And we need to transpose that onto the accelerometer data. So we've got that fast motion on top of our big slow accelerometer wave. The control system for this droid is going to be based around some electronic parts from SparkFun Electronics. So the most crucial part, of course, is the inertial measurement unit, which is a 9° of freedom unit. It has accelerometer, gyro and magnetometer on. We're only going to use the accelerometer and the gyro to start with in 2 axes. So basically it's got 3 sensors in 3 axes, which makes up the 9° of freedom. So the actual chip is the tiny black chip in the middle of this board, and SparkFun manufacture this breakout board. They've also got a lot of information on how to use it, including quite a comprehensive hookup guide and tutorial. So there's an Arduino library, lots of links for hardware assembly and so on, and an actual practical example to get you going there using an Arduino Uno. So there's some principles explained there about what each sensor does. There's also lots of data and a nice tutorial there on how to breadboard this thing up and connect it. The Arduino I'm using is 5 volts and the sensor is 3.3 volts, so we need another little level matching board. There we go, there's another example for Arduino, and there's some example code to get going, which is what we're actually going to base this whole build on. I'm going to be using the SparkFun Arduino Pro Mini, which is a very small Arduino board, and that's going to be the main brains of the droid. The motor driver board is the Rover 5 motor driver board from SparkFun Electronics. That's quite a large board, but it is quite fully featured. So it will drive up to 4 motors from 8 digital pins, a PWM pin for speed of the motor, and a direction pin for each motor, so that makes up 8 for 4 motors. It also does current sensing, and it also has inputs for quadrature encoders. So I'm not going to be using encoders on the motors to start with, but we could add those in the future, so the board can actually tell if the motor's moving as it expects and apply more current if it's not. So it seems like that's going to grip quite well. But the polystyrene, I'm quite conscious that it might get dented, and I don't really want that to happen, so I'd quite like to put a harder wearing coating on this, probably something quite grippy. So I think I'm going to rubber coat it with liquid latex. I'm using wood glue to glue the 2 halves together, and I've just applied some pressure there with a fruit bowl so that the seam line runs around this way and they get nicely glued together. So it's time to paint the ball with latex. I'm using standard liquid latex off eBay, and I also have some white pigment, so latex dries a kind of browny yellow colour, but if you pigment it with various colours you can get it to dry a different colour, so I'm using white. Latex is really easy to paint as well, so we can put all of the features and things on afterwards rather than using polyurethane or some other rubber that's a bit harder to paint. So I've mixed that up in a pot, and I'm going to use sponges to apply it to my ball to get a nice smooth coating hopefully. And I've just propped the ball on a bucket so that it stays upright. And we'll just go all over with this. While we're waiting for that latex to dry, we need to build a mechanical assembly to hold the motors, the electronics, batteries and all of the other stuff. So there's more to it, but this is the first part. So what we've got is this big blue base, and we've also got some motor mount pieces in green there which hold the motors. Now the motors have a kind of red collar that covers the gearbox, so that fits within the hole in the green part, and the bridge over them there is so that we can push down some pressure on top to hold all of those at the right angle. So they need to all be angled down, and they hinge about these gold parts, so there's actually a hole all the way through the green part there, which is a hub, so they can be hinged. And then we need to push down on them to hold them at the right angle, so there'll be another layer that sits on top of this with some foam pads that pushes down on top of these green bridge parts. So I think we'll get this printed out, see how it looks, see how it matches with the dome, and then we'll plan the next layer, which is also going to hold the electronics. Here it is. So these pieces are of course separate, which mount the motors in quite nicely. They just fit in like so, and there's 4 screw holes to screw those on. So they will be hinged, and these little black parts are removable. They fit in quite nicely, so I can put a bit of an axle through those, and the holes in the back of those are kind of blocked when they're inserted, so the axles won't come out. So let's get all of that screwed together, then we can try it on the ball and decide which angle these need to face down so that the wheels always have both tracks on the ball. I've got 1 coat of latex on my ball. You can see there's a couple of issues there. I'm going to go over it with another few coats, but I've just put the robot on top of it there with some stuff blocked up underneath. You can just see stacked up to try and get this angle for the wheels right so that they touch the ball properly. So I think that looks pretty good. Both rubber tyres, when the wheels are in the right position, touch the ball. So I think that's where we need to position them. So now I need to build another layer on top of here with some nice foam pads that rest down on top of each kind of tunnel thing that the wheels are in. The next layer is this orange table looking thing which has 5 legs. So I've got one upside down on the right there and one fitted in place on the left. And if you remember, I left a kind of keyway in the middle of the blue piece, right in the middle, for that centre leg to fit into. So we've got holes there for the motor wires to run up and also to save filament, and you'll notice the green things are actually colliding with this object and sticking through, but obviously those are hinged downwards. And in fact I've left an extra 10mm gap to put some foam in so that it could apply equal pressure to all of the green motor mounts, so effectively it makes a compliant base, so they can all be pushed down with batteries and things on top, and that will hopefully apply equal pressure to each wheel. So we need to get that printed, and then we need to make some electronics mounts and battery mounts to go on top of that. So here's my base, which is looking pretty good. I've soldered the wires on before I put the next layer on, and it has a cunning feature that we can set it like that, which is quite useful. So here is my orange base that I've just printed, and it's got this thing which keys into the middle, as I mentioned. That's 3mm longer than the other things, which are just going to be acetone welded on there. So that should neatly fit in there, and that will help make this much stronger. Obviously these edge things aren't fixed on by much, so they're quite bendy without it. So that's why I've got those extra supports at the end, if I can get that back on there. Alright, so we can get that mounted, and obviously the holes come through for the wires, and I can also get to those terminals if I have to maintain them, which is quite useful. So I've got quite big holes there I can just about get a soldering iron through. And I've also made a little motor mount, motor driver board mount, which is just 2 bits of ABS. I can weld that on there. So then we're going to have batteries either side and another layer for the actual electronics. Just to give you an idea of size, let's bring back in the dome, which is going to sit at about that height. So obviously we've got absolutely loads of space in here. You know, I can put batteries in and another layer with the electronics in, and there's still tons of space in that dome for all of the things. So here it is. We've got the motor controller board mounted nicely in there with the motor wires attached. I 3D printed some battery holders, which have got a bit of foam either side, so the battery goes through that way, and there's a Velcro strap. And I've also printed these other black stilts, which hold the circuit board on the top, and I'm using some breadboard for now, which I've got all of the SparkFun components attached to, so that I can prototype it. We've also got the radio control portion to come, and eventually I'll replace that with a proper board. So the only error I've made so far, of course, is that my inertial measurement unit needs to turn round so that it basically runs with the axis of the wheels. So I'll have to turn that board round 45 degrees somehow, but it's fine for prototyping. Under each wheel I've got a little foam block and a plastic shim which those things rest on, and it seems to be quite good. It's got the wheels at the right angle there, so they always grip as I move this thing around. Looking at it from above, we can see that all of the wheels grip the ball properly, so whichever way I move it, they all grip. And even if I lift this up slightly, they all grip really well, which means that the rubber wheels on the ball and the rubber ball itself has got quite a lot of traction, so it doesn't even need anything pushing down on it. And I've still got the batteries to mount on the dome and some other things, so that's going to be absolutely fine to provide enough traction to balance, hopefully. And this whole thing kind of weighs quite a bit, so it should be quite a lot like our lightweight stick with our heavy weight on top that I showed you at the beginning. So in case you were wondering, my ball is still actually balancing on a bucket, which is why it doesn't roll away. Obviously the robot will have to actively balance on there using the sensors and motors. So just putting our dome back on top, we've got plenty of options for the height of that. I think it goes about there, but there'll be obviously another bracket which holds it. It'll probably be stuck on with magnets or something, so I can remove it to get to the electronics. And we are going to see the wheels showing there a little bit, but you know, we can't do everything the same as in science fiction. But anyway, that's all I've got time for in this episode. In episode 2 of the BB-8 droid, we're going to be doing some coding, so don't forget to subscribe to my channel for updates on this project and other projects, and also check out the links in the description for the website article that shows where you can get all the parts and what I've used, and also my social media pages.